Okay, so today we'll be talking about antiderivative. Okay, in this course so far, we focus our attention on derivative. All right, in today's lesson, we will focus our attention just the opposite process of derivative, that is what we call antiderivative. So you will learn more about antiderivative and integrals in your another math course, Math 105, but I'm going to give you just a flavor of what that Math 105 looks like. Okay, in Math 105, what you do is in this course, Math 104, you work so hard to find the derivative of different kind of function. And in Math 105, what you're going to do is you will work so hard again to do exactly the opposite what you did in this course. Okay, antiderivative. All right. Let me just recap what we did in this course so far. We started with the concept of limit and simple geometrical idea of slope of a tangent line to a curve. We then developed the ideas further into a combination of theory about derivative and their properties, techniques for calculating derivatives, and application of derivatives. Okay, these are the things we did in this course. Now, this section, particularly in today's lesson, this section deals with the calculus concept of indefinite integral, which is also known as antidifferentiation, all right, or antiderivative. Now, we know that derivative gives the rate of change when the total amount is known. The reverse of finding derivative is known as antiderivative or antidifferentiation, has many business applications. For example, our derivative turns a profit function, p of x, into a marginal profit, p prime of x. And antiderivative, also known as integration, turns a marginal profit function, p prime of x, back into a profit function, p of x. Okay, and then we write this way. So our profit function, total profit function, p of x, is antiderivative of derivative of profit function. Remember, this antiderivative and dx always comes together. That's the symbol. Okay, it's just a stretch, s, and you just stretch that s, and that is the symbol for antiderivative or integration. We call it antiderivative integration. All right, so by the end of this unit, you will be able to evaluate the indefinite integral. Indefinite, so definite integral is out of the scope of this course. You're going to learn that definite integral in Math 105. Even this indefinite integral, this section you will learn in Math 105 as well, but I'm just want to give you a heads up. Okay, so the goal of this lesson is evaluate indefinite integral using the basic integration formula and use initial condition or boundary condition to determine an antiderivative. Now let's look at few examples here. Okay, let's look at few examples. Suppose you are given a function here and derivative and antiderivative. Suppose you are given a function, let's say your function is x squared over 2. And in Math 104, in this course, what you're going to do is you find the derivative. Can you tell me what is the derivative of this? 2x, right? Derivative is 2x. So that means not
Just
2x.
X?
Yes,
Just X? Yeah.
exactly. I was checking how many of you are paying attention. Thank you, Q. You are the first one to figure that out. Okay, so it's just x. So the antiderivative of this will be, you know, if you do the antiderivative, you should get x squared over 2. So that means antiderivative is x squared over 2 dx must be, I mean, x must be x squared over 2, x dx. Okay, antiderivative of x must be x squared over 2. In the same way, let's try a few more. Suppose you are given a function g of x equals, let's say, x cubed over 3, and your derivative is going to be, so your antiderivative, I mean derivative is going to be x squared. So that means your antiderivative of g prime of x, which means x squared dx must be x cubed over 3, right? Now let me ask you one more question. Suppose my function, instead of x cubed over 3, if I have x cubed over 3 plus 10, what will be the derivative? Same thing, x squared. If my function is, let's say, 100, for example, g of x equals x cubed over 3 plus 100, the derivative will be the same. Now antiderivative and the original function do not match up, right? So what we need to do is we need to write plus c in each of these antiderivative, because there may be a constant, and when we find the derivative of the constant, that's going to be 0. So we must add that c, whereas c is called the constant of integration. Constant of integration. If there is nothing, let's say if my function is simply f of x equals x squared over 2, that means constant is 0. In this case, x cubed over 3 plus 100. So in this case, your c value is 100. Okay, so just keep that in mind. Now let's try one more. Let's say h of x equals x power 4 over 4. Now your derivative is going to be x cubed. So your antiderivative of x cubed must be x power 4 over 4 plus c. Now, if I continue doing this, did you see a pattern there? Okay, let me just erase this and we look at those expression only. All right, let's see. Now look at the pattern. When there is this 1 power and the derivative is x squared over 2. When the power is 2, the derivative is x cubed over 3 when it is x cubed. Now if I continue doing this, I want you to tell me, if I have my function x power n, what is that? Excellent cue, thank you. So notice what we need to do is, basically this means if there is 2, there is 3 and 3. If there is 3, there is 4 and 4. So if there is n, then it will be x power n plus 1 over n plus 1 plus c. So this is one very powerful formula. It is called power rule. All right, so keep that in mind, power rule. And this power rule works for every value of n except one value that doesn't work for that formula, which is when n equals -1, it doesn't work. Okay guys, n equals -1, it doesn't work, because if n equals -1, then this bottom part will be 0. It means undefined, so it doesn't work. Now let's look at few more questions. Now here is a a formula making process you already know. Let's do a few more. Let's say your function is ln x. All right, what is the derivative? 1 over x. Okay, or you can say x power negative 1. That is your derivative. Now, according to this antiderivative, that means if you do the opposite of this x power negative 1, you should get ln x. All right, because x must be non-negative. So for that reason, I just use the absolute value sign, because logarithmic and negative 1 doesn't make sense. It's undefined. Therefore, x must be non-zero. I mean non-negative and non-zero as well. So plus c. So that's another formula. This is formula number 1. You can say this is formula number 2. Let us develop another few formula. Suppose you are given a function e to the x. What is the derivative? It's the same, right? So remember, here we have a function, and here I'm writing derivative, and here I'm writing antiderivative. So formula number 3. So antiderivative of this e to the x must be the same, e to the x plus c. Now suppose you are given e to the kx, where k is a constant, over k, for example. What is the derivative? Derivative is ekx. So the antiderivative is going to be e to the kx dx is going to be e to the kx over k plus c. So opposite of that. Okay, we are doing the antiderivative, so it's going to be that. In the same way, you can actually, you learn the formula making process. So you can make the formula yourself, okay? Just in case if you forget. Now, let's do a couple of more. Let's say my function is sine x. So what is the derivative? Well, it is cosine x, right? So another formula can be antiderivative of cosine x is going to be sine x plus c. Okay, antiderivative of cosine x is sine x. Suppose my function is cosine x, and what is the derivative? Well, it is negative sine x. And if my function is negative cos x, then my derivative is sine x. So another formula you can write is antiderivative of sine x is negative cosine x plus c, and so on. All right, guys, so you can make the formula yourself. Now, let me list all of those possible formula here. Okay, power rule, we just discussed this. And when x power negative 1, then you will have natural logarithm x. We already discussed that. Oh, by the way, if you're given, let's say, dx only, what is the formula then? What this means is dx means you can write 1 dx, right? So 1 means x power 0 dx, which can be, using the power rule, you can write 0 plus 1 over 0 plus 1 plus c. So basically it is x plus c, all right? So, and then if there is a, let's say, 5 dx, for example, then your antiderivative is going to be, you can write this 5 dx, which means 5 dx means x plus c. So you can write this way, okay? So here is the formula. K dx will be kx plus c. In the same way, we have just noticed, we have just looked at the formula for exponential function. And there is another formula for a raised to power kx. And we have all of these formulas. So we're going to use this formula to solve some of the problem here. All right. Now let's look at example 1, part A. So using that formula, you can 9 plus 1 divided by 9 plus 1 plus c, which means x power 10 over 10 plus c. Done. Any question, guys, using the power rule? Now it says evaluate by using integral formula and check your answer by differentiation. Let us check whether our answer is right or wrong, okay? Let us check it. I'll check here. So we want to do the derivative of x power 10 over 10 plus c. And do we get x power 9? Let's look at that, okay? We can check, you can check your answer yourself just by derivative. So the derivative of the first one is, okay, so 10x power 9 over 10 plus derivative of c is 0. So that's going to give me x power 9. Yes, we got that. As you can see here, x power 9, and here also we got x power 9. Yes. So it checks. Okay, our answer is right. Now let's look at another one. Part B, 5e to the 5x dx. A lot of time, you know, the 5 constant rule, I want to write that outside to make life easy. I just want to write this way. Now 5 and then the formula. Let us look at that formula. E to the power 5x. We have already seen that formula. E to the kx is e to the kx over k. So that's going to be 5e to the 5x over 5 plus c. So this 5 cancel out. So you're going to get e to the 5x plus c. Now let's check our answer. So derivative of the first one is e to the 5x. Using the chain rule, we need to find the derivative on the top, which gives me 5e to the 5x plus c is 0. Derivative of c is 0. So that's what exactly we got, right? So you see 5e to the 5x, and we got the same thing, 5e to the 5x. Yes, our answer is correct. That's how we can do. Let's try one more, and then you will do the remaining by yourself. Okay, I'm going to send you to breakout room, and then you'll be working there. Can you tell me which one you want me to do? I'll do one problem here, and then I will send you, well, yeah, one problem, then I'll send you to the breakout room. Tell me which one you want me to do. Okay, let's try part E. So part E is 1 minus 3 e raised to power negative 1 plus x.
So someone said G.
Okay, we'll do that as well. All right, no problem. Let me do this and then. Okay, one thing that whenever the functions are, you know, the variable are not given in power, for example, sometimes they will give you this, and I want you to write down in that power form so that it will be easy for us to use the power rule, okay? Always change it into power. For example, in this part E, 1, and then that x power 1 on the denominator, I'm going to bring it on the numerator. And x power 4 in the denominator, I'm going to bring it to the numerator by making them negative. Now, I can write this a couple of ways. One method is I can write this as 1 dx minus 3x power negative dx plus x power negative 4 dx. Okay, I can do that way. Now 1 dx is, I think we have already said earlier, right? What we said is that this will be simply x plus c. Let's minus this 3 This one is ln x plus c. That's the formula, right? So x power -1, look at the formula. We have seen that formula somewhere here earlier, here. So I can write that, c2 plus, this one will be x power -4 plus 1 divided by -4 plus 1 plus c3. So I get x minus 3 ln x. I can write this way, 3 ln x plus c2 plus this one. So x minus 3 ln x, and this will be plus, minus x power -3 over
可是你知道为什么吗？我现在上这课呢，我从哪里开始上呢？
So what I get here is that I'm gonna get x minus 3 ln x minus 1 over 3x squared plus c, where c equals c1 plus c2 plus c3. All right, and you can do the check yourself. I leave it to you. You know how to find the derivative of each of these guys and make sure that you get that. Now, this is 3x cubed, by the way. Okay, instead of doing this, from now onwards, what I'm going to do is, I don't have to write all of these steps. For example, I can write 1 minus 3 x power -1 plus x power -4 dx. So from now onwards, what I'm going to do is I can use directly the formula. So 1 dx, the derivative of, antiderivative of 1 dx will be simply x. I write that, minus 3. Antiderivative of x power -1, which is actually ln x. Okay, you see, even if you have c1, c2, c3, at the end of the day, all of these are constant. So you can change those constant to another constant. So you don't have to write that c1, c2, c3. We just write c at the end to make life easy. Okay, guys? So I know that there is one c is coming, c1 is coming there, but I'm not going to write it. I just write the constant at the end. So the antiderivative of x power -1 is ln x. And then antiderivative of x power -4 is x power -4 plus 1 divided by -4 plus 1 plus c at the end. That's it. This one looks a little ugly, so we just want to write one more step, and negative, you will get 1 over 3x cubed plus c. Done. So I'm gonna use this so that we can save some time. Okay, you don't have to show every step there. So this one is fine. Now checking, like I said earlier, you can check it by yourself. Okay, and somebody asked me to do G. Okay, let's try G just for fun. I trust that you can do it, but we can do it, no issue there. Let's try part Z. The question is integration of 2 over pi sine x minus 2 cosec square x dx. Did I copy the right question? Okay. Two over pi sine x dx. minus cosec square dx, right? Now 2 over pi sine x. What is the antiderivative of sine x, by the way? We have written the formula. Can you tell me, somebody?
Minus cos, negative cos.
Minus, yes, negative cosine x. Thank you. We're going to write c at the end, okay? We're not going to write c1, c2. If you want, you can do it, but you don't have to. Minus 2. What is the antiderivative of cosec square x dx? So recall from your chapter 3 that derivative of cot x is what?
Minus
Cosec square x,
Yeah.
right? So therefore, derivative of negative cot x is cosec square x. We know this. So we can use that as a formula, or the formula is already written there. We have written the formula here. But even if you forget the formula, you know the formula making process. So you can make your formula yourself. That's really powerful skill, by the way, guys. So cosec square x dx is minus cot x. So let me just write it down here. So cosec square x dx will be minus cot x plus c. Done. That's the answer. So it looks a little ugly. So let us write it in a nice way. So you're going to get negative 2 over pi cos x, negative, negative, positive 2 cot x plus c. Done. That is your answer. And you can actually do the checking by yourself. Derivative of minus 2 over pi cos x plus 2 cot x plus c equals derivative of cos x is negative sine x, so that's going to give me 2 over pi negative sine x plus 2. Derivative of cot x is negative cosec square x plus derivative of c is 0. So what we get here is negative and negative is positive, 2 over pi sine x, and then minus 2 cosec square x. Okay, and it checks. That's the same question given here, as you can see. Sorry guys, I completely forget to record this example 2, but anyway, it is here. But example 3 is also very similar. So we're going to do that example 3, and hopefully that will help you to be able to solve another example 4 problem. Okay, so let's look at example 3. Given that marginal cost function is, okay, marginal cost is given. Find the total cost function CFX. If 3 units of product cost $10. Now this is given in English word, and we need to change that English word into mathematical language actually. So what is given is, let me just write down what is given. Given that C prime of X, which is the marginal cost, equals x squared minus 2x, and then the initial value also given. So 3 units of product cost $10. So what it means is C of 3 equals 10. That is given. Now our job is to find C of X. Guys, can you try this? It's pretty much the same thing that we did earlier. So I trust that you'll be able to do it, but let's complete it just for fun, okay? We know Okay, I use k as a constant of integration because there is already c there, so people may get confused between this c and this c. So for that reason, I just want to use a different constant k. Yeah, q, thank you. This is my equation 1. Substituting the condition, the value given in the initial value condition, you will get c of x is 10 equals x means 3 cube over 3 minus 3 square plus k. All you need to do is find the value of k. And solving this, your value of k is, can somebody tell me what is the value of k here? Is that 10? Okay, q got 10, and I think that's the correct one. So your value of k is 10. Now substituting this value of k in equation 1, we get c of x equals x cubed over 3 minus x squared plus 10. Now, one thing I just want to mention, this is sometimes called a general solution. Okay, later in Math 105, you will learn in detail, and sometimes this is called general solution because it is very general. We don't know the exact value of k. K can be anything. And once the condition, initial value condition is given, you are able to figure out what is the value of k. And once you find the exact value of k and substitute this in that equation, and this equation sometimes called particular solution. Particular solution, because we got, for particular value of k, when k is 10, this is the answer. If k is different, then you'll have different answers. So it is called sometimes a particular solution. Okay. Now, if you have any question, let me know. Otherwise, I think you will be able to solve this example 4 by yourself, and I leave it to you. Just take a few minutes and let's try example 4. Okay, let us read the questions very carefully, and then once we put everything in mathematical language, then I think you guys will be able to carry on. But let us write everything in a mathematical language, okay, in our own language of mathematics, then you will be able to handle. So what is given here is given marginal revenue, which is 100 e raised to power negative 0.1 q plus 10. This is our marginal revenue. Now we need to find R of Q. We need to find the revenue function and then demand function later. But first, we'll find revenue function in part A. In order for this, we need to know the initial value condition. So what is the initial value condition here? Initial value condition. Can somebody tell me what is the initial value condition here? Is it given in the first place?
I think no.
Okay, now remember, if the initial value condition is not given, we'll not be able to calculate the particular solution, or will not be able to calculate the revenue function. So if the initial value condition is not given, we just say that it is not, not enough information given, and we just stop there. Okay, example 2 and 3, the initial value condition is given explicitly. It's not difficult to, I mean, the initial value condition is given clearly. But here, even though it's not clearly given, but you can figure it out using common sense. Remember, revenue function. So if you sell 0 item, what is your revenue?
0.
Yes, right? Even though it doesn't give us the, initial value condition clearly, but we know that using our common sense, if you sell 0 of the item, then your revenue will be 0. So that's what the initial value condition is, using common sense. Common sense is very important in many situations, guys. Okay, so here is the initial value condition. Now you can calculate yourself without any difficulty. So we know in part A we need to find R of Q. That's what we need to find. So to find, let me write to find R of A in part A. To find R of Q, we know R of Q equals dq using the formula. This will be 100, just I copy that 100 as it is, and then using that formula there, negative 0.1 q over negative 0.1, right? We know the formula because you see the formula is ekx dx equals ekx over k plus c. But c, we're going to write the c at the end. So using that formula, you'll get this plus 10 dq will be simply 10q plus c. So that is your, antiderivative. So let me write this in a nice way. I got R of Q equals 100 divided by negative 0.1. That's going to give me negative 1000 e raised to power negative 0.1 q plus 10q plus c. This is my equation 1. Now, another one is initial value condition. Given initial value which is R of 0 equals 0. So substituting this value, in 1, we're going to get R of Q will be 0 equals negative 1000 e raised to power negative 0.1. Q means 0 plus 10 times 0 plus c. And solving this, what do you get if you solve? So somebody already got the answer, and c is 1000 q. Thank you. And c is 1000. I trust that this is the right answer, but please verify this answer is correct, other people. Okay, so c equals 1000. So substituting the value of c, in equation 1. Equation 1 is general solution. Now we are able to find the particular solution because the value of C is 1000. In equation 1, we get our particular solution will be R of Q equals 1000 e raised to power negative 0.1 Q plus 10 Q plus C is 1000. 1000. This is our particular solution. Any question, guys, so far? And the last question is part B. Part B is find the demand function. So to find the demand function, okay, what is demand function? Well, demand function can be represented P equals, you can represent that P as a function of Q, or you can represent Q as a function of P, whichever is easy for you. Okay, that's the demand function. So in this question, I don't know which one is easy. So we know that what we know is we know price times quantity equals revenue. Everybody know that, right? Price times revenue is price times quantity. Okay. So which one will be easy here? So let me just put this value here. P times Q equals R. We already know R is negative 1000 e raised to power negative 0.1 Q plus 10 Q plus 1000. So we already know that. Now, which one will make life easy is I think we want to write P this side because everything is Q on this on the right hand side. So I want to take that Q to the other side. And so we got the demand function as P equals function of Q. So that's going to give me 1000 e negative 0.1 Q plus 10 Q plus 1000 divided by Q. So this is our demand function, okay? So this is our demand function in terms of price. Oh, demand function. Price P equals this. All right. Alternatively, you can express that, you can also write, alternatively, you can write Q equals function of P as I mentioned earlier. Okay, you can write this way too, but this one makes life easy. You can just stop there. Do you have any question, guys, so far?